Okay, so we should have, you're good. We should have our week 10 notes out. Week 10. So we have been working with solving quadratics, and we're going to continue with that today. However, a big part of quadratics is the graph. A big part of quadratics is the graph. So I am going to, what are you looking for? The what? Oh, okay. So we're starting notes, okay? So today we're going to talk about the things that are important in a quadratic graph. So the objective for today is that you can graph a quadratic function in standard form. We're not really going to do vertex form. I'm going to cross that out. You'll do that in math too. But we're going to graph it in standard form and in factored form. So we're not going to use the vertex form. So I'm going to cross this out. Okay. So a quadratic function is the graph of a quadratic function. Do you guys remember what this is called? Because I've told you before. It begins with a P. It's a parabola. P-A-R-A-B-O-L-A. Parabola. Okay, that's not going to work. It's just going to leave streaks all over. Okay. There are three forms to quadratic equations. We're going to use two of them. Right? So the three forms are standard form, This next one right here, this is vertex form. You can label it, but you're not going to use it in Math 1. You will use it in Math 2. This last one is what we've been doing. We've been doing this right here, this factored form. Yeah, we've been factoring our quadratics. So up to this point, we've been given a function in standard form and we've been transforming it to factored form. That's what we've been doing, right? And that makes it easy for us to tell some things about the solutions. But now we're going to talk about things about the graph specifically. So if A, do you guys see this little guy right here? That's typically the number that's attached to the x squared, okay? So if A is positive, then our graph opens up like this. I'm going to say that it opens up and I'm going to put a smile there. It makes a smile. That's what I call that. So when your graph is positive, it smiles. Positive, it smiles. Okay? When it's positive, it smiles. So if your graph is positive, it smiles. Yeah, but not yet. Yeah. Okay. So the next thing I want you to know is that if A is negative, what do you think is going to happen to your graph? Yeah, it's going to open down. It's going to go like this, open down, and it's going to make a frown. That's how I remember those. So it opens down, it makes a frown. Upside down, yep. So all quadratic equations have what is called a vertex. All quadratic equations have a vertex. So I'm going to sketch a graph over here and just show you that the vertex would be this point right here. That is my vertex. Okay. Awesome. So that's your vertex. Graphs also are symmetrical. They're symmetrical across the axis of symmetry. I need to make that bigger so I can spell that out. Maybe I just need to write it below it. It's called the axis of symmetry. I'm going to write that. I'm going to write the word symmetry below the line because I can't fit it on there. S-Y-M-M-E-T-R-Y, the axis of symmetry. So when I look at that sketch that I just made over here, your axis of symmetry is this like little dashed line, and it cuts the parabola in half. So you guys, I'm hoping, understand symmetry. Symmetry just means, like, remember when you guys learned about symmetry, it's like how many ways you can fold something so it lays exactly on top of itself, right? So this little Post-it note has a line of symmetry here, right? Here's a fold line, but I could also fold it in half the other way. And if it's a perfect square, I can fold it diagonally. And this will let me fold it diagonally as well. Okay. So it just depends, but your axis of symmetry is just, I want you to think of it as a fold line that makes the shape lay right on top of itself. Okay. So the formula that we use to calculate that, well, wait, hang on, which runs through the vertex. We need to put that word here. It runs through the vertex. And the formula that we use to calculate the axis of symmetry and the vertex, well, first of all, we start with the vertex. X equals negative b over 2a. So this is going to give you an x equals some number when you're done. And that's this axis of symmetry, AOS. That's what that's going to give you. X equals some number. Okay. We know that a quadratic function crosses the y-axis at the, what's it called when a graph crosses the axis? It's called a what? An intercept. Yeah. So it crosses the y-axis at the y-intercept. Okay. Says that the y-intercept has an x value of what? If I'm crossing the graph on the y-axis, what's my value of x? 0. So I want to tell you something special about the y-intercept. It says for a parabola, the y-intercept will be the point 0, C. If it is in, God bless you, standard form. God bless you. So when a quadratic function is written in a squared plus bx plus c, when it's written in standard form, that last number is your y-intercept. That tells you where the graph is going to cross the y-axis. Okay. Questions about that first off? Okay. We're going to slide up a little bit. Does everybody have this? Okay. So we're going to draw some pictures here in this space, and we're going to do some labeling. So it says that a quadratic function crosses or touches the x-axis 0 times, 1 time, or 2 times. And you can use the numbers if you want. Instead of the words, you can write the numbers if you want. So I am just going to create some, I'm going to just draw some quadrants like this. 1, like some graphing axes. 2, I want you to draw 3 graphing axes, just like this. 1, 2, 3. They don't have to be perfect. I'm going to label the one that's laying horizontal X. And the one that goes up and down vertically, I'm going to call Y, because that's how our quadrants are labeled, all right? That's what our graphing axes look like. So you're going to make 3 T's, 3 cross lines. Space them out like that. And we're going to draw examples of what it means that a quadratic function crosses or touches the x-axis 0, 1, or 2 times. We're going to draw examples of that so you know what it's talking about. So for our first one, we're going to cross the x-axis 0 times. So this is going to be an example of when our graph never crosses the x-axis. This one is never, ever going to cross the x-axis. So it's going to look something like this. Is that graph, do you see how those arrows on the end are going to go on forever? Is that graph ever going to touch the x-axis? No, it's above the x-axis, right? And the arrows, it extends forever in the positive direction. It's never going to touch the x-axis. This point right here is called the what? What do we say that point is? It's the vertex. This y-axis is actually, the y-axis actually becomes our AOS, which stands for the axis of symmetry. That y-axis is actually our AOS, our axis of symmetry. Let's do an example of when it crosses or touches, maybe not crosses, but touches one time, okay? So an example of when your parabola would just cross or touch the x-axis one time is something like this. So I'm just touching the x-axis right there. I'm just touching it right there. Again, that little green dot is my vertex. And this dashed line right here would be my axis of symmetry. And then I'm going to give you an example of when a parabola would cross. So this was one time, right? I don't think I wrote that down here. I'm going to put one time right here. So here's an example of when your graph would cross or touch the x-axis 2 times. What about this? What about that example? So this is my vertex. This would be my axis of symmetry. And the 2 places that it touches the x-axis are here and here. Those would be the solutions of the quadratic function if I were to solve it. So this is an example of when it touches 2 times. Now I made that graph go the opposite direction that all the other ones did. And I just did that to tell you one more thing about a graph. So the vertex, if you look at the first 2 examples, is the vertex the highest point on the graph or is it the lowest point? If you look at if you look at my first 2 pictures that I drew, the first 2 sketches, is the vertex the very highest point on the graph or is it the very lowest? What is it? It's the lowest, yeah. So here's something that's important to know. And I'm just going to write it right here. When A is positive and your graph does this, your graph looks like this, your vertex is called a minimum. because it's the lowest point on your graph. It's called a minimum because it's the very lowest point on your graph compared to when A is positive, the vertex is the minimum. Do you see that? The vertex is the minimum. Where if you look at the very last example that I did, A is not positive, A is negative because that graph is going in a frown, right? Do you see how my graph is frowning here? So in this example, A is negative. So I want you to look at the vertex there. Is the vertex here the highest or the lowest point of my graph? It's the highest. So when A is negative, your vertex is not a minimum. It is do you guys know what the opposite of minimum is? It's a maximum. So it's important to know that because when we do word problems, it's going to say, what is the highest point? Or what is the lowest point? When you see the words highest or lowest, it means, hey, find the vertex. That's what it's asking you, okay? So in this graph, we're just going to do some labeling. So I labeled some points on here. So here's what I said. I said this point right here is my y-intercept. And I said that is 1, 2, 3.5. So that's the ordered pair 0, 3.5. So my y-intercept takes place at 0, 3.5. My vertex is this point right here. It's the highest point on my graph. And I said that that's the ordered pair 1, 4.75. 1, 4.75. So that's what your vertex is. Your vertex is an ordered pair, 1, 4.75. The axis of symmetry is that imaginary fold line. So I drew a dashed line that goes right through the vertex because we said that the axis of symmetry goes through the vertex. And it's a vertical line. So I'm going to just draw a dashed line that goes right through my vertex. And the equation for the axis of symmetry is an x equals 1. Because it's a line, it's a dashed line, and it's x equals 1. And then we have to find the 2 points where this crosses the x-axis. We have to find the 2 points where our graph crosses the x-axis. So I said it crosses the x-axis here and here, and I named those 2 points. I know it's not a great picture, it's because it shifted. But I said that those points were negative 1.25, 0, and positive 3.25, 0. Those are the two. That does not look like a negative 1. It's negative 1.25. I know, I'm fixing it. Negative 1.25, 0, and positive 3.25, 0. So we are going to do this first one like manually. And then we're going to do the second one where it says you try using Desmos because I want you to see how beneficial Desmos graphing is for you, okay? So if you flip your page over, we have an equation written in standard form. So the first thing that I want you to look at is, tell me, is A positive or negative? Is A, this value right here, is it positive or negative? It's positive. A is positive. That means that my graph is going to look like a smile. Okay. So let's calculate, first of all, the axis of symmetry. That's going to be our imaginary fold line. So the axis of symmetry is the negative of b, so the negative of -8 over 2 times a, which is 2 times 4. Well, the opposite of a negative is a positive, and 2 times 4 is 8, and so it does equal 1. Now remember, this is an x equals equation, so your axis of symmetry is at x equals 1. So where x equals 1 on my grid, I'm going to draw a dashed line. Negative, -8, because it's negative b, right? So it's the negative of -8. B is -8. So I did negative of -8. I'd say the biggest mistake students make is that they see that b is negative, and so they just leave it that way. Like, oh, it's already negative, but it's asking you for the opposite of b. That's really what it's saying. The opposite of b. Okay? So we know that x equals 1. So to find the vertex, you plug the x equals 1 back into the original equation. So we're going to evaluate the function at f of 1. So instead of x, I'm going to replace the x with a 1. So put that into your calculator. 4 times 1 squared minus 8 times 1 plus 1. And you should get, so 4 times 1 squared minus 8 times 1 plus 1. Did everybody get -3? Okay, you should. So the vertex is at the point, so I'm jumping down here to where it says vertex. The vertex is at the point x is 1, y is -3. So I'm going to plot that point on my graph. I'm going to go to where x is 1 and y is -1, 2, 3, and I'm going to put a point right there. That is my vertex. That is my vertex at the point 1, x is 1, and then I have to go down to -3. So let's list the key features. What is the value of a from our function? Say it again. 4. What is the value of b? And what is the value of c? Okay. So is this parabola going to open up or down? We already said up because a is positive. Is this parabola going to have a maximum or a minimum? A minimum, yeah. When a is positive, it has a minimum. And we just graphed it. We just graphed the lowest point because that's our vertex. We said that the axis of symmetry is at x equals 1. We already drew that line. And we already know what our vertex is. Look up at the equation and remember what I told you about the y-intercept. So we said that when your function is written in standard form, the y-intercept is what value? It's the ordered pair 0, because x is 0 when we cross the y-axis. It's the ordered pair 0 what? Do you remember? Flip back to the last page. 0c. Yeah, it's 0c. So what is the value of c in this equation? So that means that our graph is going to cross the y-axis at the ordered pair 0, 1. So I'm going to plot that point. So at 0, 1, this is where my graph crosses the y-axis. Now here's why, here is one of the reasons why parabolas are so cool. You guys see that dashed line that we just drew? That axis of symmetry? We said that that was a fold line. So I have a point, my vertex right here, right on the fold line, because we said that the vertex is on the axis of symmetry. And my y-intercept is right here. How far away is my y-intercept from my axis of symmetry? How many grids away is it? It's 1 grid away. It's 1 grid away to the left. So I could put a point right here, 1 grid away to the right, because that's what symmetry means. Okay? So let me go over there and show you exactly what I'm talking about. So you see that my graph is only one grid away. That graph, that ordered pair, my y-intercept is one grid away on the on the left from my axis of symmetry. So I can go one grid away on the right and plot another point because that's what symmetry means. So if I were to fold this, they match up. They lay right on top of each other. Okay. So we have to pick one more point. We have to pick one more point. So we're going to evaluate. So here's what you need to decide. Do we want to use, the next point is 3. We could use 3 or -1. Which one do you want to use to evaluate your function? 3 or -1? Hello, anyone? -1? Okay, so here's what it's going to look like. F of -1, we're plugging in -1 to our equation, equals 4 parenthesis -1, the quantity squared, minus 8 times -1 plus 1. So I'm going to work this one out in my brain. What is -1 times -1? Say again. +1. So 4 times 1 is 4. What is -8 times -1? A +8 plus 1. So what does that equal? It equals 13. So our next point is -1, 13. And that actually isn't going to even fit on our graph. It's not even going to fit on our graph, but I'm going to draw it up here anyway so you guys can see it. So I'm going to erase all of this. And I'm going to show you that when x is -1, this graph is going to go all the way up to probably right here. We're going to say that this is the point 13. We're going to let y equal 13 here. And when x is 3, it's also going to be at 13. Those points are going to be right across from each other because of our axis of symmetry. No. So now I want to connect the points because it's a parabola, and I have to make it small for it to fit on my grid at one time. So because this is a parabola, when we connect our points, it makes a curve. That's not beautiful, but it kind of looks something like that. That's pretty horrible, actually. Let's try again. So that's kind of a parabola, right? It's not as pretty as it should be, but that's the idea of a parabola. Okay. So do your very best just to connect the points. The next one where it says you try, we're going to actually go to Desmos and do that. We're going to go to Desmos and do the next one. Where do you put what? Here, just put them. Yep, right there. Just anywhere. And then put the other one right across from it. So you're going to start here and go down and come back up. So I'm going to go to Desmos because I think that Desmos is beneficial. We're going to input, I'm going to go to Desmos and I'm going to input this equation right here into my y equals in Desmos. Okay. I want you guys, while I'm going to Desmos, to fill out this because I know that you can. Look at the equation and tell me what the value of A, B, and C is. Write it down on your paper. Okay, well, it's posted. The filled out notes are posted and we've got a video. So we're never going to get through these.
What about A, B, and C?
I just said I want you guys to fill out what A, B, and C is from your equation, right? So look at the equation. Y equals -1/2 x squared plus 2x. Fill out the values of A, B, and C. Can you do that? What is the value of A? This is your A in standard form. What is the value of A? We said A, we've been working with A since we started factoring. What is A? It's -1/2. So put that there. A is -1/2. You guys know how to do this. A is negative 1/2. What is the value of B? B is 2. It's not including the x. It's just the coefficient. So I have negative 1/2. B is 2. And what is the value of C? Negative 1. Okay. So is this parabola going to open up or down? How do you know? Why? Because A is negative. It's going to open down. And it's going to have a maximum. Axis of symmetry. Remember that equation? X equals negative B over 2A. So what's that going to look like? What is B? So negative 2 over 2 times a negative 1/2. That's going to give me my axis of symmetry. So what is negative 2 divided by negative 1? Because that's what half of 2 is. What's negative 2 divided by negative 1? It would be a positive 2. So your axis of symmetry is going to be a dashed line right here at x equals 2. And now I'm going to pull up Desmos, and we're going to figure out all the other stuff. Okay. So does everyone have their dashed line drawn at x equals 2? So I'm going to go to Desmos so you can see. The next thing that we need to find is the vertex. And technically what we need to do is we're going to plug in this x equals 2 right here for all of our x's. Okay. That's how we find the vertex. But I'm going to go to Desmos and show you a picture. So here's my dashed line. This is the line at x equals 2. I'll actually put it in there. You can see it. And I can make it dashed. Okay. So there's my dashed line. The first question is, what is the vertex? Where's the vertex on this graph? What's the vertex is going to be an ordered pair. So tell me the ordered pair of the vertex. So someone go point to the vertex. Someone go point to the vertex. Cece, go touch the vertex there. Take a marker and plot it. Just put a marker on that point. Okay. So what is that point? Good job, ma'am. What is that ordered pair? It's the ordered pair 2, 1. So that's your vertex. So for vertex, I want you to guys write the ordered pair 2, 1 in the blank. That's my vertex. Okay. What else do we need to know? What's the y-intercept? What is it? The y-intercept is an ordered pair. The y-intercept is an ordered pair. 0, -1. Yeah, so 0, -1. And the label for that is going to be y-intercept. And that makes sense because my last term, C, is -1, right? It says -1 for my last term. What else do we need to know? What's that last button say, or that last blank say on our? We need a point. We need a point that's not labeled. Well, we already know that, let's see, if the y-intercept is at 0, -1, how many units away is that from the 2 units to the left? So 2 units to the right. So I know the ordered pair 4, -1 is going to be on the graph. Okay, so I can't use those 2 points. I have to find a different one. I need to find another point that goes somewhere exactly through this grid. Do you guys see a point that the line goes exactly through a grid line? So when x is -2, y is -7, we say it in xy pair, right? So when x is -2, y is -7, that's our other point. So what is another point opposite of that? What's the point opposite of that? How many units is that point away from the axis of symmetry? How many units away is it? How far away is this from the axis of symmetry? 4. So that means I can go 4 in the other direction. And so that's the ordered pair. What? What's this ordered pair? It's 6, -7. An ordered pair is 2 points, right? So the next point is going to be 6, comma, -7. I'm going to label that one point 2. You need to have 5 points. Every parabola requires that you have 5 points. No, but on your graph, you're going to sketch this. So I'm going to leave this up here, and you're going to copy this graph. You're going to copy this graph onto your page, okay, if you haven't already. Copy this graph onto your paper. I know your graph goes down to -7, so you can just plot those points. It goes all the way down to -7, so you can just plot those points. Okay. Something. Okay, we got to finish our notes. So flip over to the next page once you get that graph copied. Flip over to the next page once you get your graph copied. So -2, -7, and 6, -7. And our vertex was right here, 2, 1, 2, 1. So parabola. God bless you. Does everyone have a parabola drawn? Yeah? Okay, go to the next page. No? Who said no? Do I need to keep that up there? Or are we good? Okay, next page. All right, so this one is going to be written in factored form. So the cool thing about this is it tells us our two solutions, and we can find the axis of symmetry when it's in factored form just by finding the average between the points. So we're going to start off with the axis of, well, first of all, let's talk about, so this is written in factored form. Do you guys remember what P and Q represent? Think about when we wrote factors. What are these two numbers? Like if I said I had the factor x plus 2 and x minus 3. What are those two numbers? Do you know? CC? I didn't hear what you said. Say that again. No, it does not. P is just a variable. What did we just do yesterday? If I know that my two factors are positive 2, x plus 2, and say again. If I know that my two factors are x plus 2 and x minus 3, what are the solutions? Yeah, x equals -2 and x equals +3. Notice that x plus 2 is the same thing as, here's why that works. Notice that x plus 2 is the same thing as x minus -2. Do you guys see that? X plus 2 is x minus a -2. That's why this happens. So these P and Q, these two numbers that we have right here, are called the roots or the zeros or the solutions or the y-intercepts. All of those mean the same thing. Not y-intercepts, sorry, x-intercepts, or the x-intercepts. They all mean the same thing. Or the x-intercepts. I would write down all of those words, all of them. P and Q are the roots, the x-intercepts, the zeros, and the solutions. They tell you exactly where the graph is going to cross the x-axis. Okay. When your function is written in standard form, you can do something really cool. You can use this to find your axis of symmetry. Say that again. Sorry, when it's written in factored form, yes. When your equation is written in factored form, you can take your two roots, add them together, and divide by 2. You have to use the two roots, okay? You have to use the two roots. So let's first of all look at this first equation right here. So what is the first root? So it's the ordered pair 1, 0, right? Because the x-intercept happens when y equals 0. What is the next root or solution? So -2, 0. So we can find the axis of symmetry by taking the two roots and adding them together. So 1 plus -2 and dividing them by 2. So what is my axis of symmetry? Well, what is 1 plus -2? -1 divided by 2 is -1/2. So the axis of symmetry is -1/2. The axis of symmetry is -1/2. 314. Okay. So we're going to do number 3. I'm not going to do number 4. Sorry, we're going to do number 2. I'm not going to do number 3. It's posted. So number 2, what are the two solutions right there? Y equals 0. Y equals 0. So what are my two solutions? What is it? Yeah, they're both -3 because x plus 2 gives me a root of -3. So if I want to find the axis of symmetry, I have -3 plus -3 divided by 2. So that tells me that x equals what? X equals -3. Make sure you sign out, please. Okay, we're going to do this first one using what we know. We're going to do this first example where it says key features, and then we're going to be done. So the graph of the function. So it says, hey, what is the value of a? So look at this equation. What is the value of a? It's -2. A is -2. So because a is -2, is that graph going to open up or down? It's going to open down. And is it going to have a maximum or a minimum? It's going to have a max. It asks you for the axis of symmetry. So we have to talk about the two x-intercepts. What are the two x-intercepts? No, you do not. What are the two x-intercepts? Yeah, it's 3, 0 and 2, 0. So that means that my graph is going to cross the x-axis at 3 and at 2. So if I want to find the axis of symmetry, I take 3 plus 2 and divide it by 2. And what does that give me? 3 plus 2 is, divided by 2 is 5 halves or 2.5. Yeah. So my axis of symmetry is going to be right in between those 2 points. Now remember, this graph is going down, so we have to find the vertex. We have to find the vertex. So in order to do that, we take the x of the axis of symmetry and we have to plug it into the function. We have to plug it in. So I'm going to write that right down here so you can see my work. So the AOS happens when x is at 2.5, and I have to take that and plug it into my equation. F of 2.5 equals -2. I'm just replacing x. So x minus 3 becomes 2.5 minus 3. And x minus 2 becomes 2.5. Whoops, sorry, minus 2. So let's see. Let's do some simplifying. What is 2.5 minus 3? -0.5. And what is 2.5 minus 2? A positive 0.5. So put that into your calculator so we can get the vertex. Put it into your calculator. It's going to be the 0.25 comma something. What's -2 times 0.5 times a -0.5? Yeah, 1/2 or 0.5. So that means that my vertex is right here at the point 2.5 and 0.5. It's very tiny. It's right there in the middle of that grid right here. There's my vertex. I don't know if you can see it. I'm going to draw an arrow to it. So we have 3 points right now. We just need 2 more. We just need 2 more. So can we find the y-intercept? Can you find the y-intercept? Yes. Well, think about when you factor or when you FOIL stuff out, you take all the constants and multiply them together. That's your y-intercept. So your y-intercept is -2 times -3 times -2. So what does that become? What is it? It should be a negative. A negative times a negative times a negative is a negative, right? Yeah, it's going to be way down here at -12. And that means the point opposite of that is going to be way down here. We're going to practice this again tomorrow. We're going to practice this all week. So that's kind of a sketch of your, parabola.